Alright guys, sorry about that. For some reason the video canceled out, so we're picking right back up where we left off. I don't know if the other one will let me upload it, but it crashed in the middle of our lesson. So once again, this is 3.6 arithmetic sequences, and we're on page 163, number 12. So right here we're having plus 3, plus 3, plus 3, plus 3. So f of n equals our first term plus our common difference, so our first term, plus our common difference times n minus 1. That's our formula for arithmetic sequence. So when I distribute this, I would have 3 plus 3n minus 3. 3 minus 3 is 0, so it's really just going to be 3n. So f of n equals 3n. Well, let's see if this works. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15, so it works. So our answer is f of n equals 3n. Let's go to our next one. What's going on here? What are we adding? Anybody? I can come up with the rule easier than I can come up with the common difference. Is that weird? Can you guys see that this is 1 over n, 1 over n, 1 over n, 1 over n? F of n equals 1 over n. 1 over 1 is 1, 1 over 2 is 1 half, 1 over 3, 1/3, 1 over 4, 1 over 5, and so on. Make sense? All right, a recursive rule for each sequence. Assume that the domain of the function is a set of consecutive integers starting with 1. Okay, so what do we know? We know that f of 1 equals 8. And then we know that f of n equals f of n minus 1, the previous term, right? The previous term plus what? What's our common difference? Plus 1. Plus 1. For n is greater than or equal to 2. So we need to take our first term, plus 1 is our second term. Our second term plus 1 is our third term. Our third term plus 1 is our fourth term. Our fourth term plus 1 is our fifth term, and so on. Right? So here, f of 1 equals 2, and f of n equals our previous term plus what? Plus 2 plus 4 plus 8 plus 16. Is that really helping us? This is an arithmetic. It's really times 2, times 2, times 2, times 2, right? This is geometric. So it's really our previous term times 2. Right? 2 times our previous term. F of 1 equals 27, and f of n equals, let's see, minus 3, minus 3, minus 3, minus 3. Right, or plus negative 3. So it's going to be our previous term f of n minus 1, our previous term, minus 3. For n is greater than or equal to 2. Right, it always has to be greater than or equal to 2 because you have to have at least one term given to be able to go from there. Write a recursive rule and explicit rule for the arithmetic sequence. So 3 plus 4 plus 4 plus 4. F of 1 equals 3. F of n equals f of n minus 1, the previous term, plus 4. That's our recursive. What about for our explicit, right? Our explicit so for our explicit, we're going to have f of n equals our first term plus n minus 1 times what? 4, right? Because you're adding 4 n minus 1 times. Okay, f of 1 is 19. F of n equals the previous term. Let's see, minus 10, minus 10, minus 10, minus 10. Our explicit, f of n equals our first term, minus 10. How many times are you subtracting 10? N minus 1 times. So negative 10 times n minus 1 plus that 19 that you had originally. F of 1 equals 1. F of n equals, all right, so what's going on here? 5 over 2 is 2.5, right? So are you adding 1.5? What are you adding? Yeah, 1.5, right? 1 plus 1.5 is 2.5, which is 5 halves. Plus 1.5 is 4. Plus 1.5, yes, plus 1.5. So your common difference is 1.5, right? So it's going to be the previous number plus 1.5, which is 3 over 2. 1 and 1/2 times add 3 over 2, right? And then for recursive, f of n equals your first term plus 3.5 times n minus 1. You're adding 3.5, 1 less than the number of terms. First term plus, you're adding 3.5, 1 less than the number of terms. All right, so your homework on this is page 165 and 166. 165 and 166.